A very good afternoon, all the participants. My name is Dr. Vignesh. I'm part of the National Digital Library of India team. And on behalf of the P N Panicker Foundation and the National Digital Library of India, we are very happy and honored to invite Professor Sambit Datta, who is the Dean of International Faculty of Science and Engineering of the Curtin University, Australia. And Professor Datta is an architect by profession. He studied architecture at the School of Architecture, Center for Environmental Planning and Technology at Ahmedabad, India. And he completed his Masters of Architecture at the National University of Singapore. And he did his doctorate in the field of computational design at the University of Adelaide. Professor Datta is also a recipient of the Michael Ventris Memorial Award from the Institute of Classical Studies, Cambridge. He was also a Michael Ventris Memorial Scholar at the Architectural Association in London. And Professor Datta, I had an opportunity of listening to his lecture during the KEDL 2009 at December last year. And to be very honest, I was mesmerized with the kind of work that you have been doing. And from that day itself, in fact, Sri Balagopalji, who is the vice chairman of the P N Panicker Foundation and the son of Sri P N Panicker, is also was also there during that webinar. So he was very insistent that we take you for this webinar. So we contacted Professor Das, and through him we have invited you for this webinar, and we are very grateful for accepting our invitation, Professor Datta. And Balagopalji.
Yeah. Can I speak?
Yes, sir. Please kindly go ahead.
Okay. Professor Dattaji, I'm very much happy to welcome you to our midst, because we were fascinated by your speech, and Dr. Vignesh told me of your interest in architecture and digital technology. Yeah, and through digital technology, our temples, etc., can be remodeled, and our culture and tradition can be kept. That's a new area, and I am eager to hear you, eager to watch your webinar as well as learn from you. I'm again welcoming Professor Datta to this August meeting. Thank you, Dattaji. Hello.
Yes, sir. So over to Professor Datta for starting his presentation.
Thank you, Dr. Vignesh. Thank you, Dr. Balagopal. Can I ask if I can share my screen? Because it says host disabled attendee screen sharing.
Just give me a minute, sir. I'm just giving the option. Yes, you may be able to do it now.
Okay, thank you. So good afternoon, everyone, and thank you very much for joining this webinar. And I'm very, very honored and pleased to present to you my research and work around the digital reconstruction of temple architecture. So I guess you can now see the screen.
Yes, sir.
Full screen. And so what I want to do today is to repeat largely the talk that I gave in IIT Delhi in December, but also make sure that I cover all the points that Mr. Balagopal has mentioned about recovering our heritage, architectural heritage, using new technologies. And hopefully it's a bit technical in nature, but I will try to keep it as open and broad-minded. And if you want, you can just ask Q&A, you can put some questions there, and maybe we can answer them to your satisfaction after the end of this talk. So the talk is about 45 minutes. So please give me that time to explain to you some of this work, which has been going on for the last 20 years. So it's quite a large body of work, and I'll try to make it as less technical as possible so you can all enjoy the fruits of the research. So first, I want to give you an overview of the temple construction for about 500 years, from 400 CE, Christian era, to about 900 Christian era. And if you look at the contemporary map of India and Southeast Asia, and you can see the dots. So this, temple tradition is not only in India, but in the far west in Pakistan, in the salt ranges near Afghanistan, and in the far east in Vietnam, in Mison, Hana, and so on, Hualai. And then it also goes south all the way to Indonesia in the central Java, where you have very large temples in the second part of this period, 400 to 900. So I'll be focusing only on very small area of 500 years, but over a very large geographic spread. So obviously in India, the temple construction, the earliest ones were here near Bittergaon, near Lucknow, and Nachna and Deoghar. This area of India had the earliest temples that we know. And then of course it spread west, it spread east, and it spread south. And this happened, in around the 5th century, 6th century. And then we find at the same time the spread of temple architecture to this region here in Cambodia, what is present-day Cambodia and Vietnam. So we speculate that there were sea routes, maritime trading routes, which went from India, south and east of India, to Southeast Asia, and various temple traditions were taken there. So we have studied Central Java, and I'll cover some temples from there, Myanmar and Cambodia. We have not covered Vietnam or Malaysia or Thailand as yet, and we have covered some of the typical early sites in India, which you are familiar with. So this is the kind of range of temple construction that you can see, right from this picture on top here from Gujarat, around 10th century, 7th century and to the 10th century. And then this is from Myanmar, entire temple cities, which of course you're familiar with in South India. But this particular one in Myanmar is Bagan, and it is having about 8,000 temples. The entire city is made up of temples. It's quite extraordinary. So what is the motivation for this work? We want to be rescuing the knowledge, the ancient knowledge, which is the unique character of temple architecture. It is involving mathematics, geometry, and a lot of science. So we really do want to understand, what kind of knowledge led to these temples being constructed. Secondly, we want to record and archive, the cultural and urban heritage, not just of India, but also of the whole of Asia. And we want to record and archive this. I guess I'm speaking to a lot of librarians and scholars. You will understand that, this is becoming a huge area of research and government policy around cultural heritage. We also, the third objective is to provide early connections by looking at temples in different parts of Asia, and what are their commonalities, what are their characteristics, and how they are connected. The fourth item is to capacity building in South and Southeast on architecture and urban conservation. And hopefully through this capacity building with conservationists, archaeologists, we can transfer these new technologies from research institutes to local experts. So initially, of course, we are only doing the research, but it must be applied. And this application process is very important. So the capacity building and technology transfer is very, very important. And finally, the thing is that we want to raise awareness of our cultural, social, spatial, and urban heritage. If you look at contemporary cities today and contemporary architecture in South and Southeast Asia, the urban development is not in keeping with the traditional values and spatial and urban way of life. So this is being lost, so raising awareness of how cities were planned, temples were planned, environment was planned is very important. So in this larger scope, what I wanted to do in my research was to look at how these temples from very small shrines, being built over and over again, spread right across this vast landscape, right all across India and Southeast Asia. And how did the form of the temple change? How did the type of the temple become so complicated? I wanted to understand that. And secondly, I was very interested in digital computational technologies for reconstruction. How do you model these things with computers and also with mathematical knowledge? And thirdly, I was interested in heritage as cultural capital. So a lot of the socioeconomic role of heritages, of different types of heritage, living communities, environmental knowledge. All of this was documented in temple construction and temple building traditions. So it not only was just about the shrine or the god or the orientation, it was also about the land, the water sources, the landscape. It was a sustainable model of work. So very quickly, today's topics I want to deal with, I will show you digital reconstructions, how we actually select, preserve, and collect digital data sets of temples at various scales using various techniques. Secondly, I'll show you how we use the visualization tools, large-scale visualization, simulation, to share these digital data sets with colleagues and with the public. So the first one really is about acquisition, and the second one is really about dissemination. And a third aspect that we are now doing a lot of research on is reconstruction of scale prototypes. So we're using 3D printing technologies to actually make copies of artifacts and reconstructions. So I'll cover these three topics, and hopefully you will find it quite interesting. So how do we actually generate this reconstruction of temples? The first thing we do is we do field surveys. We go to the field and we collect information. We use the library research. So we will go into the archives and find information about those temples. And then we will use a process called photogrammetry, which is basically image-based modeling. We take a lot of pictures of the field and then measurements from this. You can calibrate these photographs to take measurements. And we create a 3D point cloud, which I'll show you, from which we then cut up the point cloud in 3D into various dissections in plan and section. And then using parametric modeling, we make 3D reconstructions. So in terms of output, we get conjectural ones. So where the temple is not in existence, only the little artifacts remain or parts remain, half of it is missing or broken down. Then we do the 3D reconstruction by looking at the rules, of this temple construction, which we have a lot of prototypes for. And finally, we do the 3D scale prototypes, making models, small scale models. And the fourth one, which we haven't done yet, but there's a lot of research going on in India, is augmented heritage, which is basically combining the digital model and the scale model together. So you can see the reconstruction and the existing today. And this is a very interesting area of research being done in various research institutes. So this is in brief our record methodology. So today I'll show you these temples. I will show you some from Western India, this particular one in the eastern part, some from Myanmar, and some from Indonesia, and maybe one from Cambodia. So these 4 or 5 temples will give you some idea of what we've been doing. So I'll start with Myanmar because it's one of our later works, and this is from a circular city which was planned in Myanmar. It's an ancient city called Pew, and it's a well-planned city. So you have a circular wall, and then you have a temple complex, you have a royal complex here, and some of the remains, and there's a water body around it. And these circular cities are described in ancient Hindu texts on how to plan them, and this is now in the World Heritage Site. So what I have done here is, nowadays the city is no longer there, it's only remaining as, I'm only taking these 3 temples. One is a stupa, Buddhist stupa. One is a sort of solid shrine like this with a superstructure, squarish. This is actually solid. And the third one is a temple which has a simple shrine inside, this one here. And these 3, I will show you how we reconstruct it. So the first thing we do is, as I mentioned to you, we do the field survey. So we go to the field, and using our cameras, we are able to take a lot of photographs. This is a very simple example where the software then stitches together the photographs and builds up a 3D point cloud, as I mentioned earlier. And then the point cloud usually looks like this. So this is the photograph, this is the photograph, and then this is the 3D model. So every point on this temple is captured. And you can see that some areas are blank, you can see it's only partial. Some areas are there, some areas are missing, for example, here, And this happens because of the way in which we take the photographs. But essentially we capture, the existing temple quite accurately, as it exists. Now, this is an example of doing the interior and the exterior as well. So the same thing that we do on the exterior of the temple, we can do in the interior of the temple, and you get the same kind of point cloud. Now, this is the basis from which we can start our reconstructions. So this is where I think we are applying a lot of our research. So if you look at this temple now, we are able to analyze the dissections of the point cloud and remove some of the deformations and noise, we call it in technical language. So if I go back to the previous slide, you can see that there is a lot of noise, when the processing is done, some of the elements are not visible, or the geometry has been changed because of a long period of erosion or structural deformation and so on. So we are able to take that model and make it very clean. And that's the unique part of what we do. This is what has made our work, to be noticed all over the world, is we are able to use rule-based programming to find out the symmetries, to find out the deformations, compare them, and build very clean models. And some of it, to give you an example, I'll go back again. I'll go back one more slide. This particular feature here is only existing here, and it's broken. But we can analyze this, and we can reconstruct it quite perfectly, and we can place it on all 4 points. Because in the tradition, it won't be in only one point, it'll be in the 3 corners. So things like that. So here is a summary of just our techniques. So this is the point cloud, point cloud, and our modeling gives you very accurate and very clean models from this existing point cloud. And as I mentioned, we can reconstruct these, and even though some of the parts are missing from individual ones, we can compare them and rebuild them. Now, this is a comparison of our model overlapped with the original data. And you can see the green areas is perfect match, the red areas is slightly unmatched. But most scholars agree that we have done a pretty good job in the reconstruction process. So now I come to this part of the talk where I will talk about the individual temples. So this is, of course, from Karnataka. This photograph is taken in 1908, outside of Badami. And this particular temple is now no longer in this pristine state. It is actually quite deformed. But we can use these old photographs, archival photographs, to pick out the measurements using computer vision and image processing techniques. So this is how we do it. So if we take a model, we are able to build many layers of profiles, two-dimensional profiles, where we can use different software to measure these profiles and combine them with some kind of statistical method, which gives you a very clean profile. So we can go for a very deformed profile to a clean profile. And then we can do measurements based on rules, which can start to position these 2D profiles in 3D like this. And so out of this technique, we can also compare it with traditional measurement specifications, from the canonical texts. So for example, this is a 4x4 or 8x8 grid, 64 square mandala grid. And in the text, they prescribe how to lay it out so that you get the right dimensions at each point, and the thickness of the wall versus the size of the, the shrine. And then every item is measured from these grids. So with the computer, we can now actually simulate this very well. And we can build the complete temple by doing this kind of analysis. Okay, so this is a good example to show you. So this is a brick temple in Cambodia, and you can see here that it's deformed, because over 500 years it's brick, and some of the bricks have settled. But by using the rules of the prescribed in the Indian texts, we can then start to modify and see how much has changed, in each of the quadrants. And then we can place this grids on various temples so we can compare them. So this is the second part of the process, where we can measure individual temples and use the shastras to find out how to compare them and the grids. So this is an example from Western India in Gujarat, 10th century temple, as I mentioned, and you can see that it has a standard jagati, and then the temple sits on it. There's a porch, mandap in front, which is broken now. And then this North Indian sort of shikhar, which is curved. So there's a lot of geometry going on here, And so we try to discover this geometry by using our same techniques, So we measure all the parts, from the dissections, and then we place it in the shikhar, and then we measure that curve, and we relate it to the mathematics of dividing that grid. So now you can see in great detail here. This is from Gujarat in India. This is from, this particular one is from Cambodia. And so you can see that though it looks a bit different, the Indian temple and the Cambodian temple, but if you go inside the text specifications, we can see the similarities. Same thing with the shikhar. So we look at the dimensions as they prescribe it in the text. We make 3D models as described, and then we can find the points based on the curvature of how they find this curvature. So what they do is they take the corner and they subdivide it like that equally, and then they project it up, and then they subdivide it and get a curve. And once we get that curve, we can make the shikhar automatically. So this tells us how they use the mathematics 1,000 years ago. They simply know the control of the measurement and how to reduce this, and different scales, and the same curve is divided in multiple times to get the size of the stone that they cut. So all this was secret knowledge. Only the sthapatis and the temple priests would know these tricks, the mathematics, and it would not be communicated to the common people or written down. But one sculptor might get, be told, you have to carve this into 8 pieces. So they would get the measurements, and then they would just simply carve it. Another one would be given this piece and told, make 29 pieces out of this. But all of these pieces, the architect would maintain by using this knowledge of the mathematics. So this is a very interesting find that we have made. And so this is what I was describing, that for the sculptor, they may not know the whole picture. They only know how to cut their individual piece of stone. So if you divide it into 10 pieces, you get this, this corner here. If you divide it into smaller pieces and so on. So this was a very interesting find. Now what I have found is that a lot of the current sthapatis, they actually have forgotten this knowledge itself. They are going straight, okay, what type of temple you want to build, then they just copy it from the existing temple. But if you go back and study the old temples and use the computer simulations and reconstructions, you will find that there's a lot of variation possible here, and we demonstrate that. So this is a very good example of our reconstruction. So this is a shikhar with 29 or 30 pieces of the same carving, placed one on top of the other. And so we know how that they built the same one. They carved it, and then as you go up, it gets smaller and smaller and smaller. And as you see the geometry changing, the same motif, is put together, and you get a diminishing series, and therefore you get the curvature of the superstructure, what we call the shikhar. Same thing with the individual carving. If this is a one stone block, and then they are able to specify the bottom and the top, and then the sculpture, can be carved, because this stone is carved like this. And as they keep carving, they take these pieces out, and this is how they make the block. And this is how we see it in the temple. So very sophisticated mathematical control is there. And we have been able to find many of these relationships. Today, what the sthapati will do is he'll go to the temple and he will make a cast of this, and then he will use this. He has forgotten this knowledge of geometry. And so this is a very interesting way of doing it. So I have explained to you how we build these models. The second part of my talk is to work with the immersive environments. And this is, what do we do after we make the models? So we actually put it in very large virtual collections, which may be of interest to the digital library people. And for example, here is, why do we do this? This is a dome where a person who is in a wheelchair cannot go to this temple. But if you position the wheelchair in this dome, and the person can control moving through this virtual world. So creating this virtual immersive experience for a disabled person is a great activity, because they can go to various paths. So I will show you some examples of this from our research lab here in Curtin University. So this is the dome, and you can see that it is a projection of a fisheye lens. So the data from the computer that I showed you earlier is projected onto this. It can be aerial view, it can be temple interior, anything can be projected. And this is a hemispherical screen where you can see that this temple here is from Sachi, but you can see two views. This is for left and right eyes, so stereoscopic visualization. So you can see these lights here. I don't know if you can see it, but let me play the video, maybe you'll get better. So what you see is that this gentleman here is wearing glasses. And so you can see that the temple is to left eye and right eye. So he feels that he's immersed in this model because his left eye and right eye imagery, with stereoscopic visualization is helping. And his movement is being tracked by these sensors here in the base. You can see the 6 lights on top. These are infrared sensors. These sensors are tracking you see there's a head mounted thing on his face, there. So the model is moving as he is moving. He has no control over it. He can go backwards or forwards, and he can go in and out, and he can see that. So this is very useful to communicate with our virtual models to the audience, who are not able to either visit the temple or who want to come for a learning experience in a museum or a library to share, some of these research data sets. The other thing that we do is orthogonal section. I want to show you this because, we have a library of these models, and you can interactively slice it, like this particular video is showing. So you can slice the temple plan, you can slice the temple shikhar. This is a temple from Cambodia. And you can look at the x-axis, y-axis, z-axis. This is a very wonderful learning tool. And we are trying to develop a project with IIT Kharagpur to build, history lessons or, communicate knowledge of temples interactively. So as you can see, simply by clicking on the interface, you can, go through the various kinds of data sets. This is the raw point cloud. And you don't need a very sophisticated knowledge of 3D modeling. You just need to be able to move the cursor and the slider to get an understanding of these temples. You can also combine the data sets, our reconstruction versus the original model as it's today versus the raw data. So we hope to do further research so that we can make these available in projects such as the National Digital Library of India or even in other parts, so people can interact with these temples in an intuitive way, through these sorts of tools. And I think this will be very useful for teaching mathematics, for teaching culture, for teaching, construction, for students and for children. So there's a lot of potential for this. And now I come to the third part of my talk, which is to talk about the physical models, which I think is also a very good learning tool. and the physical models here this is built with a 3D printer, powder cast, plaster cast 3D printer. So what we do is we model the temple as it is today, and then we put the data into a computer, which then slices it again and then sends it to a 3D printer. And the 3D printer then prints it from the base until you get the whole, and you get all the fine details. The advantage of this is that you can print half a temple so that you can look inside. So this particular temple here is this one here, which is the original temple from Java. This is the model of the temple. Not all the details are exact because it's stylized to make it easier to print and so on. But you can see that there is a Jagati, all the elements are there. And then this is the 3D model, about 30 centimeters by 50 centimeters or so, half a foot. So not only that, for our scholars who study the historians, we print, this is a print in resin. It's a very fine print, you can see. This is the model that we have done. And it is actually this element here in the center of the temple. So we capture that, we model it, and then we make a physical model, and this is half the model, because this is a symmetrical one. So we have to just print another one and put it there. And scholars can look at it in great detail. So this is our machine. This is probably a few years old now, from 2000, maybe almost 13 years ago this was done. But it's still very relevant because you can see the temple. And this is the machine that prints it. These are the models, and this is the outcome. So we also foresee a lot of uses for this kind of work to help students learn history, learn about construction, learn about their heritage, simply by, of course, there are a lot of issues around this. For example, intellectual property. We never make the temple the same scale as the original because we're not allowed to. We are allowed to model these temples from the Archaeological Survey of India or Myanmar or Cambodia on the basis that we will change the dimension a little bit. Okay, so all the physical models that we have done are in this particular temple. We have done about 4 from the center of India, 3 from west, and about 4 from south. We have made models, and various scales. So here is the most amazing temple in Gwalior, and it has this kind of form. This is in Roda, which I talked to you earlier. This is from the Gupta temple in Vishnu temple, Dashavatar temple in center of India, one of the earliest. There is a 5th century text which describes this temple, and it matches exactly to the form of the temple, which is very interesting. In Java, we have modeled these temples. You can see in detail. Borobudur, which is a very large site. These are the temples in Java. And in Java, you can see that the temples are very different in many ways, in shape and form, but you can still recognize them as Hindu temples, And of course, when you compare and measure them very accurately, you can see the relationships. This is Cambodia, and Cambodia is just amazing. It's just full of temples. So we have done a few on the top, some in central and some in South Cambodia. So these are some of the Cambodian temples. This is the 8-sided temple, which I showed you earlier. These temples are really in, ruin with jungle all over them, and in fact, trees growing out of them. But we are able, with our techniques, to capture and rebuild. Some of these are very difficult. For example, this one is completely eroded superstructure. So we are still doing research on how much we can recover. And we work closely with IIT Kharagpur in these projects. So this is a very interesting example because here the problem is that this is moved out of alignment. All the blocks have separated. So we did a research project where we found a new way of modeling this. So we can take the blocks and stitch them back together into a clean model. So this is the deformed model and this is the clean model. And this is really the scope of our work, which we have done. About 34 temples we have done. And there is a book, my book is there, which describes all of them. Right from the Gupta period to, about the 10th century, 5th to 10th century, about 500 years of temple building in India, in Java and Cambodia we have covered. And you can see the range of variation, and the similarities are also there. So the last part of the study that we do is to look at all the different types of temple parts, the plans, the base, the platforms, superstructures, and the materials, and compare them. So this is in India, this is in Cambodia, this is in Java, and this is also in Cambodia. And then we compare the parts. This is in Tamil Nadu, and this is in Java. So although the construction is different, you can see how similar they are in terms of their form, because they follow the same rules. As I mentioned, I wanted to end with this last few slides, which show you the three-dimensional form of the temples from Myanmar, India, Central Java, and Cambodia. So this is, Buddhist times stupas we have modeled too. I showed you this temple, East Zegu, and they have a very different form of superstructure. And then here, here you can see the Dashavatara temple. And then you can see Meguti, which is in Karnataka, Mukunda Nayanar, which is in Tamil Nadu, the Pakshi temple, which is in Gujarat, and the Parvati temple in Uttar Pradesh, where we have reconstructed. And these three are in Java and Cambodia, and these four are in Cambodia. Sorry, this is in Java. So I guess that is the summary of my work on the digital reconstruction. I've given you a brief outline of, all the geometry that goes in to model and reconstruct these broken temples. I've shown you the visualization of these temples in the laboratory for public consumption and interaction. I've also shown you how to make 3D models from the same data, and also some new techniques for, reconstructing deformed models. So I guess I have come to the point where I'll be looking at the question and answer and understand your thoughts. That's all from me. So
Thank you. Thank you, sir. Thank you for this amazing presentation. So I still feel the same excitement as I was listening to you when way back in last year, December 2019. So before we get into the question from the participants, I have two fundamental questions. First and foremost is, why are these temples constructed? That's first part of my question. And the second question is, what excited or what motivated you to get into this domain of understanding the architecture of temples and then reconstructing them? So these are the two questions from my end, sir. Hello.
yes, sorry, I muted myself. Thank you for your questions. I guess the first question is the important one. Why are they constructed? Now, temples, if you think about 5th century, 6th century, they were the center of public life, social life. They were centers of learning. They recorded knowledge. That's where people gathered. And even today, if you look at temple sites in South India, you will see that there is a kund, there's water, people come there in the evenings. So it's a multiple, it's not simply for religion. It's also a social, urban center, if you like. The temple was a center of communal life. So the reason for constructing them is very obvious, because, just as today we make parks and gardens, they build temples. That was one reason. The second reason was to, the cosmology and the life cycle revolved around a lot of festivals and cycles of Hindu way of life. And so the temple actually became a physical manifestation of those abstract ideas, So it was an easy way to communicate and keep the community together through festivals, social events, and so on. But the third is the most important one, and that is knowledge. They kept the knowledge of construction, of good practice, environmental practices. They wrote it down in terms of rules that you should do this, you should not do that, you should do this through experience. So by constantly building temples, it was an economic engine of these communities. So there's a religious reason, there is an urban reason, there is a socioeconomic reason, and then they were the libraries of ancient communities, if you will. And the second part of the question that you asked, what motivated me, was because it was something like this, is built 1,000 years, maybe 1,200 years ago. And when I studied this first models, when I was a student, I discovered that they're accurate to a millimeter. And so the question in my mind is that how did they build these stone temples, which are so accurate that we cannot build now? If you look at our contemporary construction in any Indian city, you don't see the finish, you don't see the knowledge of construction. You see some haphazardly put together building, and most of them look very ugly. So I became interested in how did they do this fine work, and why can't we do it today? And then I discovered that it's not fine because it's just construction, but the knowledge of geometry and mathematics and science that is involved, in these stone constructions or brick constructions is very deep. And so I started to draw these up. As in the old days, 30 years ago, you didn't have computers, and computers were just coming in India in the late 80s. So I found it very, very difficult to draw these and record these objects because they were so complicated, as I showed you. So I started using computers. One of my teachers said to me, why don't you use the computer to model it? And so that's how I became interested and continue to do this research even today. And it's becoming more and more involved. And, so I hope that answers your question.
Yes, very much. I don't have words to describe the kind of work you have done. So there is a participant question. So the question is from Mr. Sumit Kumar Mukherjee. So please brief about the software you used for this tool.
Yeah, so the software here, I could give a whole 1-hour talk on the different types of software, right? So the software we use ranges from commercial photogrammetry software, like PhotoScan, Image Modeler, and so on, which allows you to take lots of photographs and then calculates, through the software algorithms. Then it ranges to 3D modeling programs, which can take in, this kind of information, point sets and so on, and analyze them. Again, we have so many different types of modelers. We use a tool called Rhinoceros, which allows us to program inside it. And so we write our own programs as well to investigate these temples. But it's a very, very good question. And I'm happy for Mr. Mukherjee to send me an email and I can, but the range is vast, commercial software to 3D modeling software to programming tools, algorithms, libraries, and so on. So it's a whole image processing, computer vision pipeline. If you are from the field, you can understand. There's no one software that does anything. And most of the time we have to write our own. So it becomes research. But what we are doing with IIT Kharagpur is that we are trying to build a kind of unified software platform to not only document, visualize, and treat these models, but also to allow museums and libraries and archives, GLAMs, if you will, to investigate these tools. We also use a number of experimental software like gaming software, which are very good visualization engines like Unity 3D, which allows us to take these models in and program interfaces for them. And of course, the software we use for 3D printing is software called Materialize, which takes digital data and then is able to turn it into physical materials. So I hope that answers partly at least your question.
Yes, sir. So participants, if you have any specific questions, kindly put it in the chat box so I can read it out for Professor Datta to answer.
Mm-hmm.
Okay, so I think, sir, I think most of the people have, they are highly appreciative of your work, and they're thanking you for this, sharing this wonderful session. I have not got any concrete questions
that's
from my participants as of now. In case if they reach out to us with any specific questions, we will share your email ID to. So, okay, Miss Nita Malik, if you want to know about the softwares that are used, so you can send an email to Professor Datta, so he will be able to help you with.
Yeah.
Yeah. So thank you once again. Thank you so much for your amazing work and amazing session, sir. We really thoroughly enjoyed it, and we would like to have you in the future of our work sessions also, and contribute richly for the National Digital Library of India. Once again, on behalf of the National Digital Library of India and the P N Panicker Foundation, we are happy to have you, and we'd like to thank you from the bottom of the heart for taking out time from your schedule to join us for this webinar. Thank you once again, sir. Thank you.
Thank you, Dr. Vignesh. It was a great honor to participate in this particular webinar, and I look forward to visiting you. And if you have any questions, please ask me, and I'm happy to share further.
Sure, sir. Thank you. Thank you so much.
All the best with your celebrations.
Thank you, sir. Thank you. So participants, I'm going to share the feedback form URL here. So kindly submit your feedback form, and then download. You can download your participation certificate after submitting the form. Professor Datta, I think we will. You may want to leave the session, so we will continue with the basic logistics.
Okay.
Thank you, sir. Thank you so much.
Thank you very much. All the best to all of you. Thank you.
Thank you. Yes, so the video recording will be shared in our YouTube channel. So kindly go to YouTube and search for P N Panicker Foundation. You will be able to see all the webinar videos. So I'm once again sharing the feedback form URL. In case if you have not registered yourself for this webinar, you are first requested to register yourself and then submit the feedback form. Okay, so I'm going to put both the registration form URL and the feedback form URL in the chat box. So kindly do that. I'm going to put this in the YouTube channel as well, so that the participants can okay. So I'm going to put both the registration form URL and the feedback form URL in the chat box. So kindly do that. I'm going to put this in the YouTube channel as well.
എനിക്ക് സംസാരിക്കാൻ പറ്റുന്നില്ല. പിടിച്ചോ.
If you have registered yourself and if you have submitted your feedback form, kindly go to our webinar page. I'm just sharing the webinar page URL. So if you have submitted your feedback form, then you can go to the webinar which you've submitted the feedback form, and then there is an option to download your certificate. So from there you can download. 98% of the participants have downloaded their certificate of participation. If you have not done so, then I think you need to do it at least now. If you have submitted your feedback form, you just have to click on this URL. I'm sending it to you separately in your chat box also. Then you can do it. 98% of all our participants have downloaded a certificate within 1 hour of the webinar. So I request all the participants kindly download it, because it's completely system driven. We don't have any manual intervention in this certificate. We can't send the certificate to your email ID individually. So you submit your feedback form and then download the certificate of participation from the webinar itself.